What is the effect of stress on material wear? Imagine a tiny crack starting on a metal surface after just a few uses. That crack might seem small, but stress can make it grow and cause big problems. When materials are used over time, they face forces that push and pull on them. These forces are called stress, and they can come from many sources like weight, movement, or temperature changes. Sometimes stress happens repeatedly, like when a machine part moves back and forth. This is called cyclic stress, and it can cause what is known as fatigue wear. Fatigue wear is when small cracks form, grow, and eventually cause pieces of the material to break off. This process weakens the whole part and can lead to sudden failure if not noticed early. Stress also makes surfaces more prone to other types of wear. When pressure is high, the material can deform or bend permanently, which roughens the surface. A rough surface increases friction, making wear happen faster. For example, if a gear tooth is under constant high stress, it might start to chip or wear down more quickly than expected. Stress can weaken the bonds between atoms on the surface of a material. When these bonds are broken, tiny particles can be easily removed during sliding or rubbing, speeding up the wear process. In some materials like diamonds or carbon-based coatings, stress can cause the strong bonds between atoms to break. This leads to the formation of atomic chains that can detach from the surface, adding to the wear. Elastomeric materials like rubber handle stress differently. They can stretch and absorb impacts, which helps them resist wear better than brittle materials. But even elastomers can develop cracks from repeated impacts or sliding, especially if the stress is high or uneven. Understanding how stress affects wear helps engineers design better products. They can choose materials that resist stress better or add surface treatments to distribute stress more evenly. For example, reducing cyclic loading or smoothing out contact points can slow down fatigue wear. Proper design and maintenance can extend the life of parts by minimizing harmful stress concentrations. In the end, stress plays a big role in how materials wear out. It starts cracks, weakens surfaces, and changes how wear happens. Recognizing these effects helps us prevent failures and build longer-lasting machines and devices.